Alright, this is lesson 69, and anyways, this is just another type of summation. You're used to doing kind of rectangles like this, except for now, instead of doing a rectangle, we're actually going to do a trapezoid. So we're going to use this side right here, and this is going to be the endpoints. And if you remember, oops, that's kind of a not so straight line here, but there's a straight line between there and there. So notice that now you have, hopefully you can tell, there's two trapezoids. All right, there's a trapezoid there, there's a trapezoid there. Now, let me let's see here. So that's what you have here. And notice that I have two trapezoids. This would be what we call base 1. This would be base 2. And that right there, basically, the height would be from here to here. Okay, so if you turn it sideways, it kind of looks like a trapezoid, all right? And you have two of those, so that's what we're going to use today. And now, anyways, everybody's trying to come in and see me the time I'm trying to record this. Anyway, so just to remind you of the left-hand sum, if you don't remember, you would have, and notice that right here, they're asking us to use two equal subdivisions. So delta x, if you remember, would be if you grab 2 minus 1 here over the number of subdivisions that they want, okay, which is 2. So my delta x is going to be half. And remember that 1/2 is the width. It was the width of the rectangle. So this right here is equal to 1/2. And to figure out the heights, if you remember, if it's a left-hand sum, like on this one, so look at the pink marking here. If it's left, to find the height of the rectangle, I have to plug it in back into this function right here. Okay, so I have to plug that back into this function. So that right there, that's what that means. If I plug in 1 back into this, I get the height of this rectangle. All right. And so we have 1/2, 1 plus 1 over 1.5. And when you put that in your calculator, that's approximately 0.833. All right, the right-hand sum would be the same thing, but the rectangles, you're using the right endpoint. So you'll be going basically from here back. So the right-hand sum in this case, because if it's a decreasing function, that's going to be an underestimation. So the number we get here should be less than the left-hand sum. Okay. So this is just kind of a refresher of what we've done in the past. So I'm going to go through this again to figure out the heights. I have to plug 1.5 back into this function, and this is approximately 0.583. Okay, and now finally the midpoint. The midpoint, well, as the name implies, you're not going to use this endpoints here. We're going to use the middle of that between 1 and 1.5, which is 1.25. And the other number between 1.5 and 2, that would be 1.75. And that's equal to 1/2, 1 over 2.5, blah, blah, blah. All of that is approximately 0.686. All right, so remember, if you remember, this is a more accurate approximation of the area under the curve. However, now we have enough information to be able to solve this by hand. So before I do the trapezoid rule, I want to show you that if you remember from the stuff that we've been doing, the antiderivative of 1 over x, or the integral of 1 over x, is just the natural log of the absolute value of x. And if we evaluate that between 1 and 2, you would get the natural log of 2. Now notice that the absolute value of 2 is just 2, so I'm just going to leave it as natural log of 2. Minus the natural log of 1, or the absolute value of 1. The absolute value of 1 is also 1. That's 0. So this would be the natural log of 2 which is approximately 0.693. All right, so notice again that it's an approximation. All the rest of them kind of come close, but not quite the same. All right, so the trapezoid rule. So the trapezoid rule works like this. Notice again, I'm going to go back to this because that's really what we're talking about. You have two trapezoids. One of them is right here. And like I drew here, this is base 1, this is base 2, and this would be the height of the trapezoid. And you have another one here with the same base for this one, but a slightly different one for this one, okay? But the same height, which the height is delta x. So again, the area of a trapezoid is 1/2 the height, base 1 plus base 2. Okay, and notice that I kind of labeled that drawing right there for you. Where in this case, when we're doing summation, this right here, the h, if you think about it, that's the delta x, right? The delta x, this is the height right here. That's the height. And that's delta x, that's the thickness of the interval. Okay. So again, we have two trapezoids. So we have the area of one. Remember that 1/2 came from the formula. The delta x in this case, the height, remember the height would be from here to here, which is 0.5 or 1/2. All right, so I'm going to write this as 1/2. So again, this would be the height. Okay, that's where that came from. Don't be confused. And to figure out base 1, well, base 1 can be figured out by doing f of 1. Remember, f of 1 will give me that point. That will give me the y coordinate, the height at that point, which happens to be base 1. All right. Similarly, to find the height at 1.5, I plug that back into my original equation. All right. So I'm going to keep using my original equation, which in this case was 1/x. All right. And then I have another trapezoid. I have another tiny trapezoid right here. All right, whose height is also 1/2. So we have 1/2 times 1/2. And the heights now would be f of 1.5, this one right here, and f of 2. Okay, so that's probably the last time I'll go back to the picture, hopefully. So I won't keep moving on you. All right, again, just in case you didn't get to the first time, this is height, this is base 1, this is base 2. That's what that is. Okay, so that's what I got. I'm going to go ahead and kind of do all the math for this. So I'm going to do it relatively quickly. Hopefully you can keep up. And I noticed I just messed up. So I'm going to go ahead and switch to pencil so I don't do that again. So I have 1/4. All right, I have 1/4. Well, here's what I'm going to do. Notice that I have a common factor of 1/4. All right, so I'm going to pull that all the way out, and when I do, I end up with f of 1 plus f of 1.5 plus f of 1.5 plus f of 2. Now notice that this right here will be the same thing as twice of f1.5, and that's important when I show you the actual equation. Okay, so I can't tell if that's blurry in your screen. It kind of looks blurry in my screen. I don't know if that's my projector or I'm out of focus, so I'm going to go ahead and switch back to pen, and I hope I don't make another mistake here. Playing games here, playing danger games. So again, this right here, from there to there, would be twice of f.5. And again, that'll become important when I show you the actual formula, right? So this right here, if we do all the math, this is 1/4 of 1 plus 1 over 1.5 plus 1 over 1.5 plus 1 over 2. And that will give you approximately 0.708. So really the only new thing we're learning here is the trapezoid rule, whose formula happens to be very similar to this. Actually, it's the same formula. So now I'm going to show you the formula for a trapezoid rule. Hopefully you understand where we got this from. Okay, so I think if you understand where it comes from, it's a lot easier to use. So let's take a look at the formula. All right, this is the formula right here. Now the formula, remember this right here would be your delta x, or your height, if you will. Because delta x, and notice that this is double. This is double the middle, right? And if you missed it the first time, if you rewind a little bit, notice that I say this is 2 times this because you're sharing a side on the trapezoid. So that's where you get that too. Anyway, so let's go straight to an example here. Now it's asking us to use the trapezoidal rule with four equal subdivisions. All right, we're going to integrate between 0 and x. Now they actually changed it here to 0 and 1. Okay, so we're going to go between 0 and 1. This is 0, this is 1, and if I have 4 intervals, well, you know, I get a half, 1/4, 3/4. Right, so that's what I'm dealing with. All right. So now I start off by putting the trapezoidal rule sum. I have 1/2, which comes straight from the formula, times 1 minus 0 over the number of subintervals, which in this case is 4. Right? And we're going to multiply that times all the heights of the, or in this case, all the bases. All right? These represent the bases of each trapezoid. And normally it's because you're sharing a side of the base with another trapezoid, you have 2 times the middle. All right? So if you don't understand that, you're just doing twice of the middle. So you can pull that 2 out. And you're going to put all the middle terms, which in this case is just, see, 1/4, 1/2, and f of 3/4. And all of these will give me all the bases, right, plus f of 1. So notice one more time that I put a 2 with all the middle stuff. The first term and the last term don't have a 2. All right, so if you don't remember anything at all, that's what you should remember. All right, so now this right here will become 1/8. Notice this is 1/2, this is 1/4, so that will become 1/8. And f of 0, well, I have to use this function, sine of t squared, right? So I'm using that exact function. So if I plug in a 0 here, sine of 0 is 0. And then twice, let's see, if I plug in a, where is it, a 1/4 into this. Okay, now that's where you really do have to use a calculator. So when I do, notice that I did that here. It gave me that number, which I'm going to round to 3 decimal places. All right, so I have 0.062 plus 0.247 plus 0.533 plus 0.841. All right, if you want to get credit for this, you must show me the setup. All right, so don't just be like, well, you know what I mean by this. No, I don't know what you mean until you write it. I can't read your mind. But obviously, you can use the calculator for all the arithmetic if you like. So the answer is that right there when you actually plug it all in. All right. Now the next one's a little bit weird. It says a town wants to drain and fill the swamp shown below. The swamp averages 5 foot deep. About how many cubic yards of dirt will it take to fill the area after the swamp is drained? So, in case you don't get it, this right here is the swamp being, like somebody took a picture from the top. So this is the swamp as it stands, and it's 5 foot deep, like that way, like into the lake, or sorry, into the swamp. So again, this is the area. We're gonna find the area of this shape. We're gonna approximate it. Now remember, the volume is the area of the base times the height. And we know the height is this one right here, 5 feet. So we know that much. All right, however, the area of the base we don't know. So we're going to use the trapezoidal rule. We're going to use the trapezoidal rule to figure out this area. All right, so notice that right here, it sort of tells you It doesn't actually tell you how many subdivisions, but you can count them here. Okay, so you can see, let me see here. You can kind of see 1, 2, 3, 4, 5, 6. All right, so we're going to have 6 subdivisions. So again, I'm using the formula from the top, 1/2. What I notice that the widths, all right, it tells me right here. This is delta x. All right, that would be 20, so this is 20. And on this one, I don't really have to write f of anything like that because they actually given me the height, so it's kind of hard to see on my paper, but you should be able to see it on your paper. This is 146. And because I'm using the trapezoidal rule to find this, all right, I'm going to use this formula. So therefore, the first term does not have a 2. The middle terms, all of the middle terms are going to have a 2. So I'm going to multiply all those times 2. And again, remember, I'm getting 122, 76 from here. See, 122, 76, 54, 40, 30. That's where I'm getting those from. So plus, where am I? Plus 54, plus 40, plus 30. Okay, that's what we got. Okay, so if you type all that in your calculator, you find out that the area of the surface of the water, this is the surface of the swamp, I'm sorry, would be that square. Okay, so this is this right here is B, which is the area of the base. Okay, now to figure out the volume is equal to that number times 5. So this is the base, or area of the base, sorry. And this is the height. And when you multiply that, you get the answer as 40,150 feet cubed. However, they want to know this in yards. Alright, so you have to do a simple conversion, if you know it, hopefully. This kind of goes back to your old science days, perhaps physics, perhaps chemistry. Alright, so if I want to get rid of feet cubed, I know that 1 yard cubed is equal to 27 feet cubed. Alright, remember this is basically 27 came from multiplying 3 times 3 times 3. Alright, so when you do all this, feet cubed cancel, end up with yards cubed, so the answer is going to be 1487.037 yards cubed. Alright, so that's the answer. Okay. So I had to change to yards because of what he told me here, right? So finally, in example 4, it says if a line x is equal to k divides the region in example 1, all right, into 2 regions of equal area, what is the value of k? So that may look really confusing at first, but so as it did to me. But first we have to go back to example 1. So I'm going to quickly show you what we got for example 1. In example 1, all right, we did all this, but the reality is the area under the curve between 1 and 2 is this, is what I found earlier, right? So that's the area of that. Now what they want me to do is split this in half. There's a line on here that splits this area directly in half. So I'm going to get half of that number, okay? So again, this right here, they want me to do the same integral, except for as between 1 and k, of 1 over x dx. And that's going to be equal to 3.4657. And again, where I got that number from, if I did this correctly, and I hope I did because I don't want to deal with this. Let's see, natural log of 2. So yeah, if you remember from my integration, so if you don't see where this is coming from, go back to my example 1. All right, I got the answer as the natural log of 2. And that number was, the natural log of 2 was approximately like 0.693 yeah, I don't know, 147. I'll stop there. And if I divide that by 2, I get, 0.34657. Anyways, that's where I got the area, right? So that's half. This number represents half of the region from example 1. All right. So in order to solve that, well, I'm going to integrate, and I know how to integrate this luckily. So this right here, the antiderivative of that is the natural log of x, of the absolute value of x, whatever is a mathematical term to say that I haven't thought about this, but we're just going to leave it like that. All right, so we have the absolute value of x. Give me a second here. Should be equal to this. So I have to continue, right? I'm going to have to plug in my values. So I have the natural log of k minus the natural log of 1, okay? It's equal to 0.34657, and the natural log of 1 is 0, so I have the natural log of k is equal to 0.34657. Now the question is, how do I get rid of this natural log? Okay, and it turns out that I get rid of natural log, if you remember from back and probably at least algebra 2, and if not pre-cal, you're gonna do the Euler's number, right? And that usually counts as the natural log. Not usually it does. Then you have k is equal to e to the power of 0.34657. And let me put this in the calculator, make sure we're going to get the right answer. So we have second e to the 0.34657. Okay, so notice that again, if you put this in your calculator, you get that. So k is equal to 1.414. Hey, this homework can be confusing, alright? So if you're confused, we'll try to do our best to try to finish it tomorrow, and we'll just see where that takes us, alright? If you have any questions, please let me know tomorrow. Goodbye.